Open up my virtual desktop.
Yeah, I opened it already.
Oh my god.
Did you guys see like the practice exam questions?
Yeah, I went over it.
I printed out to take notes on.
What time did you guys start the meeting today?
Just like a couple minutes ago.
Oh, you already went through it?
No.
We haven't.
Oh, okay.
I thought you meant like on our own.
Oh.
We started the meeting like an hour ago, just to tell you.
I was like, what? Where have I been?
Now.
Okay. So I was thinking about two things. If we're going to do the quiz, but you guys also want to go over the outcomes, like the things we're expected to know if we do.
At the bottom or where? Like here to show outcomes for the lessons.
I printed out.
I think it's mostly just kind of like review stuff.
The things that say
I don't know. I feel like we could probably refer back to it. I don't know if we have to go over it.
Yeah.
Well, more questions on it though. It'd be nice.
What do you mean there's questions on it?
It's the one that says you need to know about confidence intervals, and how to calculate a confidence interval, hypothesis testing. One thing is to show the appropriate connections between numerical and graphical summaries that support a hypothesis test. Never heard it referred to that way. I don't even know what that means.
I think if we just know how they answer stuff, how they word stuff in, like, the homework quizzes, the group quizzes, and review, if you, like, know how they word it and you know exactly how to answer it, I think that'll be fine. Like, I think that summary stuff gets kind of confusing unless you put it in your own words. Like on the last test, all I did really to study was I went through all the homework quizzes and all the group quizzes, and I looked at how they worded everything, and I wrote down little examples of everything so I could know exactly how to answer it and exactly what formula was needed and everything like that. And there was nothing I didn't know how to do. I knew how to do everything. There was just a couple mistakes I made because that's it happens. But I think as long as you do that, but if you try to, I don't know, I feel like they're kind of worded confusing, so I think after you go through everything, look back at that, then you can be like, oh, that's what that means. I don't know. But if you're kind of just looking at it cold, you haven't looked at it for, you're like, oh,
yeah.
I don't know. That's just my personal opinion.
All right. That sounds like a good guideline. So, are you guys ready for the quiz then?
The only questions I have are with SPSS.
Okay.
Well, I think we can go through it, as we go through the quiz, so we can, all visualize it,
We can take the quiz.
Okay.
I'm ready.
Because they're all, it's, the exact same question, right?
Do you have any questions right off the bat, Leah, about SPSS?
No, I think we'd have to, get there to talk about it.
Okay. All right. Okay, so we have 32 questions.
Yikes.
Yes,
Well, the first two are just, I don't know. I feel like a couple are just did you do this?
Yeah.
All right, question 2. Given a 90% confidence interval of 45 and 105 for the median part, which of the following is the best interpretation of this confidence interval? I think it's
A.
because it's the wording, like you were saying, Leanne.
Mhm.
This has to start. This one, what does it mean? It always starts out saying we are whatever percent confident. I mean,
No, yeah, it's that one.
It's B, right? We're 90% confident.
We're 90% confident that the answer is B.
Yes, that also. My confidence rating for this answer.
Yeah.
We are 90% confident that the true mean heart rate is between 45 and 105.
okay. Following information will be used for the questions. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males from that of the researchers randomly selected 20 females and 15 males to participate in the go, no-go stimulus required student to respond to a particular stimulus and not to respond to another stimulus. Researchers decided to construct a confidence interval to determine the difference of the mean significant. To determine whether the confidence interval would be reliable, they created QQ plots with random samples and if they are approximately normal. Are the requirements for constructing a confidence interval satisfied by everyone?
I think it's B, but I think it also might be
Well,
I think it also might be C.
We're not looking at any data for this, right?
No, yeah, you just have to kind of infer it.
I would say C also because they did create QQ plots.
But they didn't say if they were. Did they say if it was reliable? And
I would say that it's B because
yes.
there's 15 males and 20 females. So since that's not equal, then I feel like it would be wrong.
That's a good. Yes, except that it does say after they created these two plots, they do see that they are approximately normal.
I think the most important thing, like, because the QQ plots is important too, because you also need to make sure that the variance is the same too. So I think, does it say something about the standard deviation? Or maybe that's a different question.
I think it is. This is way back at the beginning. Kind of stuff.
I'll just read through it quickly.
Why or why not?
I don't know. Well, like, we need to see, like, for example, Charlotte, this would be, like, a good time to, like, go back and look at the, what's it called? The summary.
Yeah.
Because, it'll tell you, like, what the requirements are for a confidence interval. Hopefully. Maybe not. Yeah, it doesn't look like it. Awesome.
The distribution of the mean is normal since they've determined to be normal. Distribution.
Well, because I know they have to have a normal data set, which is kind of what they're saying when the QQ plot is normal. I just don't remember what the other.
Are the requirements for constructing a confidence interval satisfied? So, what are the requirements for constructing a confidence interval? I guess is what we should.
Yeah. So it's from less than 10.
There's margin of error. Confidence interval is an interval estimator you give range. Width depends on level. Sample size formula. Doesn't say anything about the requirement.
Okay, so if either condition I or II is met, we can consider the sample mean as normal.
Where are you reading?
3.3.2. So if the population for which the data are drawn is approximately normal, which they did say with the QQ plot, or if the sample size is large, then X will be approximately normally distributed. And then
So those are the only two requirements?
yeah.
Okay.
If either condition 1 or 2 is met, we can consider the sample mean as normal.
All right.
Okay, then yeah, I think it is normal then. I think the answer is
See?
C?
yeah.
Okay. Sorry, I think Charlotte's is a little garbly today, so I'm making sure that it's...
Yeah, I know. Everyone sounds kind of funny. Hi.
Okay. Yours is a little garbly too, Heather. We might just have a bad connection.
Yeah, I know, it's like, I don't know if it's just me or what.
No, yeah, it's kind of hard to hear people.
That's why I muted mine, because I thought mine was messing everything up, but it sounds the same to me.
I don't know, like, I think yours sounds fine to me, Leah. I don't know.
Oh,
You said fine, Leah.
okay. That's good.
Okay.
Number 4. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment?
Dependent. Okay, so sigma is unknown. So it's definitely not D, because we don't know what the standard deviation is. Sorry.
We're not looking for the differences means, right?
Well, we kind of do want to see if the men are different from the women.
Okay.
I thought it was C just because they are independent, you know, like knowing who the men are doesn't tell you who the women are, and that's the main definition of an
Yeah.
But I feel like that's just me with like my recent knowledge, and I'm also like, you know what I mean? Because like I don't know if that's, you know, for like the other two, B and D. I don't know, like, because I feel like we used to do stuff like that before, and it didn't matter if it was dependent or independent. It's only mattered like for the recent stuff. So
Yeah.
basically, we need to know if just the standard deviation is not known, right? Yeah, no.
Yeah. We just
So
want to.
I think it would either be B or C, but I think we should go with C first.
I would say C.
Yeah. I was thinking the same thing as you, Anne, but my gut goes with C. But I guess we'll find out when we take the test.
Yeah. When we get the answers.
Yeah.
Do you want to keep reading, Leah? Since you sound
Yeah, sure. Okay, a researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval is found to be those numbers, 300, 4,000, or 3,000, 4,000. Which of the following would produce a confidence interval with a smaller margin of error than the 95% confidence interval? So I had to go back for this one and kind of relearn it. What do you guys think?
I put C because I have it written in my notes that as N goes down, margin of error gets. I wrote it down somewhere.
Yeah, I'm supposed to remember it too.
Oh yeah, as N goes up, margin of error goes down, and vice versa. So I put D.
Yeah, D.
That's what I put too.
D is in dog.
Yeah.
And dog, yeah.
Yeah, and then it's like opposite for the confidence interval. Like if you go 95 to 99, that increases the margin of error.
Right.
So a factory makes propeller shafts for ships. They want to estimate the true mean length of the shafts. She selects 4 shaft drives, measures the length, and finds the sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is 2 millimeters. Calculate the 95% confidence interval for the true mean length of the shaft. Input your answers for the margin of error, lower bound, and upper bound.
So the sample size is 4.
Mm-hmm.
Standard deviation is 2.
Except for this one, we just use that formula x minus c or plus c.
Yeah.
What is the formula again? I know it's in here somewhere.
It's x bar plus or minus z. So you do one formula plus and one formula negative.
Right.
And then z, which is the confidence interval of 95, which is like the 1.96, times standard deviation divided by square root of the number.
Okay. Which is also the same as the margin of error, right?
No, the margin of error, they actually didn't ask this in the review. The margin of error, you have to do something different. I'm just going to look at my notes quick. Okay, so margin of error, you do z times standard deviation divided by number.
No, I remember now.
Leanne, what you were saying earlier, that I just want to write it down in my notes. The confidence interval, as it goes up, you said the margin error goes down?
No, so as the confidence interval, like the 90, say it goes from 95 to 99, like it does in that example, the margin of error increases. Because it's looking for something more specific, and that makes it have more mistakes.
Okay.
So, and then like the opposite is true then too. So like if you go from 95 to 90, the margin of error decreases.
Okay. All right. That
Yeah,
makes sense.
so the number is opposite, and then confidence interval follows exactly.
Okay.
Or, anyways, one is opposite and one is the same.
Okay. I think I got it. Thanks.
For question 6, did you guys get 998.04?
Not there yet, almost.
Okay.
Yes, that's what so this is kind of similar to the question that was on the review part.
It is. We just didn't get asked the margin of error. We just got asked the confidence intervals.
Right.
So Heather,
Yeah.
right now, 1,000 is the sample mean. That's x, right?
Yes.
Plus 1.645 because that's the 95% interval.
Oh, is it? I thought it was 196.
I looked on the normal probability applet.
That's probably for the
Wait,
9.
I have too much.
1.96.
The z-score is 1.96.
Yeah.
That's just like always what it is. So
No.
what did you get for the margin of error, Heather?
For the lower 998.04.
Yep.
Yeah, that's what I got too.
And then the upper bound is 1,00196.
Yeah. Did you do the margin of error, like number 6?
What was that?
Did you do number 6?
Yeah.
You
I
said,
swapped them. I always do that. I didn't read correctly.
you said your z-score was 1.96?
Yes. Yeah, that's because back in the lesson it gave you like the 3 answers.
Yeah, I
Or
remember.
like 90%, 95, and 99.
Yep, I do. So here's the other question, though. You're timesing that by
This
what?
standard deviation divided by the square root of the number.
I know, Leanne. Hang on one second.
Yeah.
You've got your standard deviation is 2. You've got your sample size is 4. Square root of 4 is 2. So basically, that's 1. 2 over 2. Did you guys get that?
Yeah.
Yeah.
So then you're just adding 1.96 to 1,000 and then subtracting it from it.
I did it all in one step, so I don't know.
What did you say?
Like, Charlotte, if you get the same answer as us, then I do that.
What were your answers?
998.04 and 1001.96.
Yep.
Then, yeah, I would just do whatever you want to do, honestly. As long as you get like if you do the same thing every time and you always get the right answer, just like keep doing it. Just like make sure you always do it the same. Don't like do like half a step different. I don't know.
So then here for on margin of error, we're putting in both these numbers?
No, those two answers are for 7 and 8. The upper and lower bounds of the 95%.
So for the margin of error, I got 1.96, but that doesn't seem right.
I got 7.8.
I forgot, is it upper minus lower divided by 2?
No, that's for, see, this is like really kind of what secretly bothers me. You do margin of error differently for different stuff. So for this one, you use a formula. You go z times standard deviation divided by square root of n.
Yeah.
And then the stuff that we learned like in lesson
Later.
12 and 11, you do like, you get it from like 1. It's different because you get it from the SPSS. So I think maybe that's the difference.
Okay. Then
7 something, Leanne?
Oh, okay, hold on.
well then Leah, I think you're right on 6 if that's your margin of error because you're doing 1.96 times 1.
That's what I did at first, but now I'm thinking it's 1,000 instead of 1.96.
Because I got 1.96 as the margin of error also.
I'm going with 1.96.
Okay.
Because it would be, I don't know.
Yeah, it is
Otherwise-
1.96.
Okay, good. I do not want to overly confuse myself.
You just set it up the way that you'd be timesing it by 1.
But I know, I just was confused when Leanne had 7. I was like, oh no.
No, it's because I like didn't put brackets in.
Okay, I was like,
I
oh
think
no.
my computer's smarter than, or my calculator's smarter than it is, but it's not smart. Needs my help.
It does.
Okay, excellent. So question 9. To assess the accuracy of lab scale, a standard weight is known to be 1 gram is repeatedly weighed a total of n times. Suppose the readings are normally distributed with unknown mean mu and standard deviation of 0.01. How large should n be so that the 95% confidence interval for u has margin error plus or minus 0.001? So I did this one wrong somehow, or maybe the answer was wrong on the computer. Anyways, I want to know what you guys get.
I have the formula for it.
No, I did the formula and everything. I just didn't get the answer that came out.
Okay. Let me,
It was missing a 0. I don't know.
I did the same thing, and then I redid the problem, only I put, point. I didn't put the 0 before the point. And then I
Okay.
added an extra parentheses, and then I got the 38416, which was one of the answers.
you're like, oh, no.
I got a super different answer. I got 196. So I think I totally did it weird.
I think it's because you have to put it. Did you put it in double parentheses when you're?
Well, I did it all separately.
I just got 196.
I'm still working.
No, see, I got 196 too, but that wasn't one of the answers that they let you give.
They're asking you to give the answer.
Because, in the review problem, the answer that was closest to that was 1960.
Mm-hmm.
So I don't know if it's, us doing it wrong or if, the answer was just...
Oh, you know what? It's because I didn't square root it. It needs to be squared. So,
Does
Yeah.
it?
yeah.
Oh, it does. You're right. I totally forgot about that.
So then what is it?
I got 38416.
38.
Yeah, I got that too.
Yeah, 38,000.
416. That's what I got too. Okay.
Oh, good catch with the square root.
See, because I remember I did that too. I was like, the formula's right, but I had forgotten to put the square. Because it's kind of tricky out there on my bracket. Okay. Now you know what you did, Leah.
Okay, all of my pens are dead. Awesome. Okay. sorry, I'm just gonna write down the answer on the thing I didn't. 38416. Save. Okay, question 10. The mean mu is several thousand, blah, 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 is advertised to be 1250 square feet. Someone thinks it's smaller than advertised. They hire an engineer to measure random apartments to test their suspicion. The appropriate null and alternative hypothesis are.
Which was the last one?
A.
Agreed.
Mhm. Okay, question 11. In a statistical test hypothesis, we say we reject the null hypothesis with a level significance of A if
The p-value is less than.
I was confused by this one.
I know this one is like worded goofy. It's like totally worded to like mess you up. So I think it's
If it's larger than... Okay, so if p-value is larger, then we fail to reject. So that's confusing.
Yeah, if the p is low, then we reject the null.
yeah. So I think it's B,
That's
but
what I
I'm
would
not sure. Yeah, because we say we reject the null with a level of significance if the p-value is less than A.
Yeah, if it's less than.
B.
Yeah.
Okay, 12. They want to determine if some apartment buildings get better grades than others. They collect all the GPA from an anonymous random sample of 15 from each of the 4 different apartment buildings. Data for each apartment are bell-shaped, no outliers, and the sample variance is nearly equal. We can use an ANOVA hypothesis to test this question.
Sample size 15.
There's some sort of difference about the sample size. We can conduct an ANOVA test when the following requirements are met. The data are normally distributed. They're talking about the data, not the sample mean being normally distributed. So
And the variances are equal for each group.
right.
But do we
So
know?
what are they talking about here? Are they saying the sample is normally distributed or the data is? That's
The data for each apartment building are bell-shaped with no outliers. So they are talking about the data.
And the sample variances are nearly equal.
I think it's C.
Yeah, it should be, right?
If it's not, then it's B.
I think they have enough, because those are the only 2 things you need.
Mm-hmm.
Okay.
Okay, question 13. Okay, so treatment for cancer, the average survival time for standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for new and standard treatment. In the early trial for new treatment, 3 subjects have a average survival of 4.5 years after diagnosis. Even though the sample is small, the results are statistically significant at 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, she determines that the new treatment does not increase the survival time in the population of all patients for this particular type of cancer. This researcher has committed what type of error?
Okay. So the null is that it's the same.
No, she rejected the null.
Right, so I just was trying to figure out what the null was.
The null is that both treatments are the same, have the same survival time.
So if she rejected the null when it was true, then it was a type 1 error.
Yeah.
Okay.
Yeah.
I was looking at my chart.
Me too.
No, yeah, I like
My notes.
write that chart down on my sheet.
Yeah, I did write it down because I was like, I'm never going to remember that.
I pictured it, the images that the instructor included with the man. Like,
Yeah, the pregnancy thing. Yeah, that was funny.
yeah.
Okay, question 14. If the level of significance A is made small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing a type 2 error?
Isn't it? As one goes down, the other increases, right?
Yeah.
Yes. So that is A.
Yes.
I'm not trying to, like, tell you. I'm just saying.
No, yeah.
I hope no one's like, okay, we got it.
Oh, Heather's so bossy, you know?
I have been told I'm bossy, so one bit
She's so smart. She's so wise at biostats.
because I'm really old.
Okay, the nicotine content of cigarettes is normally distributed with mean and a known standard deviation of 0.17. The brand advertises the mean nicotine is 1.5, but measurements of around 100 cigarettes give a sample mean of 1.53. Is this evidence that the mean nicotine content is actually higher than advertised? To answer this, test the hypothesis.
I forgot how to do that.
And I'm like, oh,
We don't know what the mean is, do we?
this evidence that the mean.
Well, we know what the sample mean is being said to be.
So I think this is when we find the z-score. So like we do like z equals x bar minus the u over standard deviation divided by the square root of n.
Yeah, I think so too.
And then we put in the applet to get the p-value.
Mm-hmm.
Okay.
Can you guys hear the TV in my background?
I don't think so.
Okay, good.
Do we know what year it is? It's saying 1.5. Okay, sorry.
Yeah, so we go 1.53, take away 1.5, right?
Yeah, that's what I did.
I like forgot which one went first.
How many samples? 100?
100.
Okay, what is the formula? I'm not seeing. I don't think I have it written down. So
You go x bar, take away mean. So I don't know if you put x or mu or something. I forget exactly what it is.
okay,
And then
experiment.
go divided by standard deviation divided by square root of n.
Oh, so that's
And
like
that gives you the z.
that's like the way old.
Yeah, I know. It's so hard to remember stuff from, like, beginning of the unit.
Is that like for the t-score? Because that's what we did for this t-score, correct?
Well, that's to get the z-score, because this is, like, a different test.
Is it the same as a t-score?
What?
I know it's not the same, but is it the same formula and you just did it differently? 'Cause
I think so.
I
Well,
have to find the t-score. So that's
Yeah.
why I'm
Similar, except instead of the standard deviation, you have an S.
yeah, like the symbols are different. But
Okay.
honestly, for most t-scores, I think you almost always use SPSS. You don't have to calculate it by hand.
Okay.
Yeah, so I think when you have to calculate stuff by hand, it's like the z-score, and when you do t-score and x-score, you always do it with SPSS.
Okay. I know, it's like, I know how to do it all, I just can't ever keep it all straight.
I know it's so hard, honestly, like because it's so similar, but then it's like, oh, this is completely different.
Yeah.
You know what's bugging me? Is I cannot get the simple answer. This is going way back to where we were trying to find out what 95% was. If I go to my applet and I select just the right side, right? Or is it the middle that it wanted?
For
It
what?
depends on the question.
I'm sorry, it's separate from this question entirely. Remember back when we were just trying to find out what the area was for the 95%?
Mm-hmm.
And it was 196? I can't come up with that answer.
Well, that's because it just gives it to you. Like
Yeah, but you'll be able to figure it out too, because we figured it out before.
what?
When you do it, don't you select the right side and put 95 up in the area, 0.9500?
No, that's from like the last unit. Honestly, like I don't think we used the normal probability applet at all this unit.
Well, I just get the answer for this one.
Well, yes, that's true.
Okay, that aside.
So it's the positive z-score of 1.765. Is that what you got?
Yes.
And so then that probability is 0.0388.
Or 0.04, which is still less than 0.05.
So then we would reject the null. Reject the, so that's D. Ugh,
Reject.
so hard to remember
I know.
all this.
Okay, question 16. Would like to look at the mean number of hours worked for wages per week by male and female students. You would like to have a random sample of 100 for each group. To test if those means are different. What is the correct statistical procedure?
Okay.
I guess independent, because they are independent of each other, but I'm never sure about these questions.
I said independent too.
Independent sample t-test.
Yeah.
That's what I would say.
Yeah, those ones are hard because, like,
I do always get them wrong too, so.
well, it's because, like, we used to kind of do similar questions to this, but we would do it for, like, well, I guess there is no z-score.
Well, I think the reason I don't think this one's hard is because you've got males and females, so they're completely independent.
Yeah, that's why I think it's independent.
Although I did watch one of the lectures from the younger guy who said if it's part of a family, then it's dependent. Even
Yeah,
though
because you have to have, like, the same family, like, in there.
Look at the next question, and that's exactly what you'll find.
yeah.
Okay, question 17. So they're interested in the academic achievement by males and females with similar academic support systems. Uses brothers and sisters raised in the same home and only brother-sister pairs if they're right next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling? Yeah, so this one's like just what we were just talking about.
So that's D, because if you select the brother, you have to select the sister.
Right,
Yeah.
and it's not B because achievement has nothing to do with why you chose them.
Okay. Just, we're choosing them because they're the same.
Yeah. Okay. Use this SPSS file for the next 4 questions. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level for each sample. The measurement is recorded in this file. The researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon levels in the fields. Question 18. Of the 4 confidence intervals listed below, which is the most appropriate for this situation? What did I choose?
In each.
So I initially said A when you went O is unknown. But I also put a question mark next to it, so wouldn't hang my hat on it.
I'm gonna go put her down for her nap. I'll be right back.
Okay.
Okay. Don't go without me because I have questions about SPSS.
No, wait, I don't think we will.
Everybody get take a stretch.
Okay.
Confidence intervals are always like super tricky for me. I don't know why they trip me up.
Okay, so these are. Sorry, not supposed to be going on.
Well, I think confidence intervals are hard because, like, you do different things for, like, all these different processes. Like, it's really confusing.
Yeah. Okay. So
How about that? We can rule out B and C because there's no way to separate these samples. I looked at the file and there's no way that designates it into groups, so it wouldn't be dependent or independent samples.
dissolve.
Yeah, so basically we just have to decide if the standard deviation is known, which I don't think it is.
Which wouldn't it give it to us?
Yep,
Well, yeah.
they would. They always do.
So I would say A also, because we're not trying to see if one field is like better than another. He just wants to know what I don't know. What does he want to know? It's just he just wants to know what the organic carbon is in each sample.
Yeah. Yeah, they want to know the confidence interval for the mean.
Yeah.
Yeah, so confidence interval for you, which is mean, when, yeah, so I think it's A.
Yeah, I would say A. Okay. So
Margin of error. Oh, we didn't do this in the thing.
Oh, but let's wait for Leah.
No, yeah.
I'm here. I have it up. I just have to. So we're looking at.
So we kind of decided that it most likely is A for 18.
Right. But well, I don't know. I'm
Well,
just
what do you
with
think?
you guys on that one because before I said it was known because if you put it all through SPS, it tells you. But
Oh, yeah, it does.
so I
Yeah,
said
but
it was known.
that's true.
Well, how about? Okay, that almost makes sense. Here's just one question to ask. We can find it out and then it becomes known, but does the definition of known mean that they gave it to us?
that's kind of what I would think too.
Well, because we had a whole lesson on what to do when the standard deviation isn't known.
And does it involve finding out what it is, or is it something completely different?
You
Well,
usually
I'm
don't know you use SPSS.
I'm gonna go look at the.
Is it like 9?
No, it was.
I think it's 10 or 11. I think maybe 10.
Uh,
Okay, sigma known is 10.
it's 11.
Sigma unknown is 11.
Okay.
We use a different. We use Z becomes T. This is when we use the student and the degrees of freedom.
Oh, yeah. So, yeah, I'm not totally convinced that, like, even though you can find the standard deviation, because, like, for this one you use SPSS a lot. And, like, under 4.11, it, like, has the standard deviation.
I'm gonna.
So even though it is sigma unknown. So I think maybe like initially that's what they're asking. They're like, is the standard deviation initially known or initially unknown?
Yeah.
So I think that might be A still.
I'm gonna put A.
I'll put it, and then we'll see what the answer is.
I'll take a chance.
So, do you guys? So I have the organic numbers up on SPSS,
Mm-hmm.
and I was thinking that you just go straight to analyze, compare means, and then one sample t-test. Is that right?
That is used.
Well, do we just want to go to descriptive statistics first?
Well, I went analyze descriptive statistics explore.
Yeah, that's what I did.
And that's what I got for the confidence interval. I just don't know for this one, for the margin of error, if we have to like do that thing where we like take away the upper from the lower and then divide by 2. I think that's what we have to do. Anyway, so
the margin of error, yeah.
so initially we need to find what the 95 confidence interval is.
Yeah, which it says it's 11.168
Yeah.
and 15.217.
And Leanne, it's upper minus lower, right?
Yeah, upper minus lower. And if the lower is negative, you go upper minus negative lower, which basically means
Right.
upper plus lower.
And you, for dividing by 2, you only do that if it's one-tailed? Or
For margin of error, you always have to divide it by 2.
oh, okay.
Yeah, that's for the p level or the p value. They need to maybe divide it by 2 sometimes.
So lower minus upper.
So Leah, do you know how to find the confidence interval then on SPSS?
Yeah, so I did it wrong initially. So instead of what I did, I went to analyze, descriptive statistics, explore, and then it came up.
Okay, yeah.
So because when you said the lower and upper bound numbers, I have the same ones. So
Yeah.
I'm assuming it's correct.
Did you come up with 9633?
No. Got
I'm still doing it.
2.024 is what I got.
I'm gonna do it again. I probably did
I
something.
got 4.049.
Divide by 2.
Oh my gosh, I literally never do that. Literally my downfall. 2.024. I guess 0.025.
How did I get that wrong? Okay, I got 2.0245.
I got negative 2.02.
Did you go upper, take away lower?
No, I did lower minus upper.
Yeah, so do upper, take away lower.
Okay.
Okay, so 2.02.
Lower bound.
I think I have that written down.
I love these questions, and I really do mean love. They ask you for the margin of error, and then the next 2 questions, when they ask for lower and upper, are given.
I know, you're like, yay! Okay, and then the upper bound, 15.217. Okay. Save.
Okay, do you guys want me to read the next questions? Are you ready?
Yes.
Okay, a random sample of Hummers for sale in LA and New York are taken from car listings. They're recorded in that data file. We want to know if there is a difference in mean listing prices between Hummers for sale, Group 1, and Hummers for sale in New York, Group 2. Create a 95% confidence interval for the true difference of the mean listing prices between the cities. Question 22. Of the 4 types of confidence intervals listed below, Which one is the most appropriate for this situation? I said C, but I'm like not very confident about that.
We want to know if there's a difference in mean listing prices. Well, yeah, because I'm not sure. Does choosing Hummers in LA
Mm-mm.
any significance on what is chosen in group 2?
No.
I don't think so, because it asks you, like,
They're just choosing it.
It's like saying male and female. It's
Yeah.
just different prices.
Just different. Okay. So,
okay, which of the following is 95% confidence interval for the two difference of mean listing prices between Hummers in LA and New York? Input your answers for the upper and lower bound.
So same thing, descriptives explore.
Well, I think you need to do the auto recode. Yeah, I don't have the files pulled up because anyway, I like wrote down exactly what I did.
Look what happens when you choose automatic recall. Look at all those options.
I know, I was like, oh.
Which one are we doing?
I think it would need to be
Is it the city?
city. Yeah. And then it's
Okay.
Right, because even in the question it says LA group 1, New York group 2.
Yes.
That's more like a little hint.
Yes, it is.
So the variables are the city. And well, are you sure that it isn't price? Because they're looking at the prices in each city.
Well, no, that's what we. Well, because right now we're just doing the auto recode.
Oh, so you just put city in the variable then.
Yeah.
And make it say city code, and that way you won't get confused when you need to use it later.
Yeah, right, city code. Good idea. And then after you do that, then you do like the individual sample test, t-test.
Compare means one sample T.
Yeah.
And why?
No. You do individual sample t-test.
independent sample.
Yeah. Oh my gosh, I'm sorry. I wrote down indie and I like remember it wrong. Yes, independent.
Yeah. Price is the test variable, and the group is the city, right? City code.
Yeah.
Yeah, so the bottom one is always the recoded one, and then the top one is what you're actually trying to figure out, which is the price difference.
Yeah. And groups are just 1 and 2, right?
Yeah.
I always forget to put those in.
Well, it won't let me hit OK if I don't.
Oh, I think in the other one it doesn't make you. Okay.
Alright, what do we want? We want the lower bound first.
Okay. So
Yeah, so what did you guys get for the lower bound?
Negative 423.158.
Yeah.
I didn't put the right thing in. I don't see a lower bound.
It should just be the 95% interval.
Because you said do the independent test, so that's what I did. I didn't do the explore thing.
You didn't do what?
I didn't do the Explore either, but it's still on the very end of the independent samples test.
Yeah, you just have to like scroll over to the end.
Okay, I've got a smaller one here. Got it.
So
And we're using the bottom one, right?
yes.
Yeah.
4, 2, 3, 1, 5.
And don't forget to put negative because that's
Yeah.
Negative 432.58. Did I get my numbers in order?
423.158.
Yeah.
Or 2, 3.
Yeah, 4, 2, 3.
Oops.
Too bad they don't ask us the margin of error, because I could totally do that.
Yeah.
All right, you guys have the upper one too?
Yep, I'm all ready.
5417.256.
Mm-hmm. Yes.
Yeah. Is everyone ready for me to read the next stuff?
I'm ready.
Okay. Many studies suggest there's a link between exercise and bone health. One study examined the effects of jumping on bone density of growing rats. There were 3 groups. The rats were randomly selected. A control with no jumping, a low jumping group, and a high jumping group. After 8 weeks of 10 jumps per day, 5 days a week, the bone density of rats was measured. The data is recorded in that file. The researchers would like to determine if the mean level of bone densities are different between the 3 different groups of rats. Use the level of significance of 0.05. What is the correct hypothesis test for the situation?
So we're recoding first, right?
Well,
Yeah, but let's just answer 25 first.
so the correct hypothesis is
Okay.
the hypothesis test.
Yeah. So is it a 1 sample t-test, a 1 sample z-test, independent test,
say-
ANOVA?
It's the ANOVA because we have 3 different things we have to look at.
Yeah, I think that's probably like the easiest one.
Because it's more than 2.
Yeah.
Well, and in the question it says they just want to know if it's different.
Yeah.
So I think
Okay, calculate the test statistic. Yeah, so we have to recode it first.
And then the treatment is what we're going to recode.
Yeah, I think so.
The treatment? I did the bone.
We did bone density. I think it's the treatment because we want to know are they low jumping, high jumping, or not jumping.
Yeah, it's the treatment.
Hold on.
So basically, you always recode the group of like people or cars or etc. Like basically, you recode the noun, like a person, place, or thing. Does that make sense?
Mostly. No, I'm mostly done with it.
And then the thing, usually that's the dependent variable, is always what depends on the thing you are measuring. Like how much something is or how, like the bone density, etc.
Okay, that was
Yeah, so then after you recode it, then you go analyze, compare means, and then you do the 1 ANOVA test.
You guys want to know what my son just said?
What?
Mom, I need some water. I'm gonna die.
Oh,
Thank you, Mom.
Okay.
don't forget to check descriptive and mean spot in the options.
Yeah.
Sorry, I'm behind a little bit because of that. We're still going to analyze and then compare means
And then 1 way ANOVA test.
because we're doing it. Okay.
I
Go ahead, Gil.
can't get
Sure you can.
it. It's great.
Options, click descriptive. I got something weird.
Do you want to like put it on your screen?
Or maybe it's... hold on.
Okay, let me know when it's on your screen.
Should be right now.
Okay.
Oh, that is weird.
Did you get this?
no.
So
I would redo it.
Analyze. Compare mean. One-way ANOVA.
Uh-huh.
Treatment code. No.
No, code goes in the factor.
You're right. Oh, geez, that's good. And we, okay.
Yeah.
That's right.
And
So-
we are taking this number, right? This is our
Yeah, so F is the test statistic.
test statistic. Yep.
I got a different one.
Wait, I got a different number too.
I have 7.978.
I got that too.
Little rats.
What did you get, Heather?
7.978.
How did yours end up different?
I don't know. Here, let me go to editor. Everything's. I'm gonna get rid of this. Yes, I can't.
Yeah, sometimes I feel like if you have more than one code thing, it like kind of messes it up.
And I made that one by mistake in the first place. We're gonna go. That's fine. That's fine. Those were already checked. Cross your finger. 7.978. That was it.
Okay, and then the p-value is 0.002.
Yeah.
So,
We're not dividing this one.
no. The,
Yeah, so
There's
for
never-
the test statistic for the F thing, you like always just take it as is.
Right.
because it's always in the right. It's never split.
Right. Okay.
Yeah, so basically all the other p-values, though, for like the sigma and the sigma unknown, you divide it by 2 if it's one field.
Okay.
So what is the conclusion? 28. Is 0.002 less or greater than 0.005? It is
Less than. So we're rejecting it, and so we say there is sufficient evidence to conclude that there's a difference.
Yeah, I think it'd be D.
I think it's A.
A.
Oh no, it can
No, I think it's
D.
I think it's D.
Yeah.
Because you state whether it's insufficient or sufficient, and then the second part of it is always the null.
Right. I agree with you there.
Yeah, and the thing that they're trying to trick you up is that all the groups are different, but it's just at least one. You don't know which one is different.
Right.
Okay, so I did this super late last night, and I didn't do the last like 4 questions, so because I wasn't doing them right. Anyways, so my answers are probably not right.
Direct.
Okay. Question 29. Let's read this whole paragraph. Blah blah blah.
Supply
So
effective.
basically, they're trying to find the price difference in tickets between 14 days and 15 days, or 90 days. Yeah. So perform a hypothesis test to determine if there's a difference in the mean cost of the nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use the level of significance.
Didn't we do the same question somewhere else?
No,
Right.
it was in the homework quiz for lesson 13.
I wish I could remember what I put.
No, I like remember what I wrote down and everything. I just don't remember how I got it because I didn't write down how I got the answers.
Oh.
Suffice to say, I was pretty disappointed. I was like, because like everything else, when I didn't know how to do it, I could just like go look at all my answers and stuff I had written down. But this one, I didn't do it. Okay, so first question: what kind of hypothesis test?
This is the dependent samples test, correct?
Yeah, because the flights, the amount of flights, or, yeah,
Like,
Yes.
the flight You're gonna look at two different things on the same flight.
Picking the same flight, yeah.
They
Okay.
depend on each other.
So
Yeah.
then recode this.
So is this a NOVA?
Yes. No, dependent.
Yeah.
Yeah, it's the last option.
Then which one are we recoding? We can't.
Do we need to recode or not?
I was kind of wondering if we needed to compute the variable. You know how you like take away one from another.
Yep, I think you're right.
Yeah. So
I just did not get the right answers last night, so let's see if this is better today.
so we're gonna take. Does it tell us which one to take?
I think you take 14 away from 90.
Yeah, I think you do take 14 from 90.
Well, and I guess it doesn't really matter. It'll give you the same thing. It'll just be opposite. And I think we accounted for that, right?
Well, you don't want to be confused.
The target variable is difference.
That's my problem with SPSS is that I don't always know whether to do, like, I don't always know what kind of test to do.
Mm-hmm.
And when I do know what test to do, I don't quite know how to do it. Well, I know how to do it.
That's why on your little sheet that you can take to the test with all like your formulas and stuff, you need to write down like like this is an example of sigma known, this is an example of dependent, this is an example, and then you have to write down like the steps and stuff. Like that's what I'm gonna do so I don't get mixed up.
I'm writing down the steps right now for the ones that we've done in case I.
No, yeah, that's a good idea. Because, like, you know how it always says, like, which of the 4 hypothesis tests is most appropriate? So I think if you guys, and me too, but I think we, like, go through and we, like, write down, like, this is how you do sigma known, this is how you do sigma unknown, this is how you do dependent, this is how you do independent, and then there's, like, different types in each one. So
Yeah.
I think if you have, like, a little example of each and then you can kind of refer back to that, then the test will be a lot easier.
So for this, are we doing the 40 days or the 90 days for the variable?
Both.
Yeah, whatever I did was wrong.
What?
So instead of giving me any answers, it's in the viewer, it just says compute difference equals 90 days minus 14 days execute. It didn't tell me anything.
I didn't hear what you said. You kind of cut out.
Okay. Instead of giving me a graph after I hit enter, all it says is compute difference equals 90 days minus 14 days execute.
That's because the difference is put, the difference is, it's put in the regular part of the data, like on the main window.
Okay. So it's still right. Okay, we're good. Because it just gives me a column. I gotcha.
So you guys went 14 minus 90, right?
No, I did 90 minus 14.
You did 90 minus 14?
How do you? So I'm doing automatic recode. Is that?
Oh, no, this is the one where you need to do compute variable.
It's still under transform. It's the second one down.
Okay. Okay, I need to write that.
So this one,
So I think it is 14 minus 90 because I remember when I did it for the homework quiz, the very top difference one was negative 32. So I'm pretty sure it is 14 minus 90 days.
Okay.
I don't know if there is a difference, if you do need to go 14, take away 90, or 90 to go 14, but I got it right on the homework quiz, and this is, like, I'm, like, pretty sure this is what I did.
yeah, well, I think they said that they're accounting for that, like, as it'll be the same answer. One will just be negative and one would be positive, and so I think that both would be right.
Oh, okay.
That's my understanding. It could be incorrect, but I think that's what they said, because there was, you know, they said depending. I know when we did all those homework quizzes and the videos, he would always say, well, your answer could be this or this depending on which one you put first. So
Okay.
Is this one where we're going to do the paired samples t-test when we do the analyze?
See, I don't know. I honestly tried so many different things last night, and I couldn't get it. So,
Okay.
When you say paired, it brings up something I've never seen before. Did you try that?
Which
Oh
one?
yeah, see, I tried that too last night, and I don't think we ever learned how to do that.
That's not the one then.
I agree. I think we still do one sample t-test, and then choose difference as our variable. And then our test value has to be what the mean is, right?
I don't
yeah.
think that is a mean. I think you're just trying to see if there's a difference, so it is 0.
Okay.
Okay, you're right. So then we do the t-test.
And value stays at 0.
The one sample t-test?
Yes.
And the variable is the difference?
Mhm.
Okay.
Oh yeah, this is how you do it. Yeah.
Okay, so try one sample t-test. Difference, and then the test value is what?
We're leaving 0?
0. Okay, that's what I thought. So then we have. What are they asking us for?
The test.
They're asking for the test statistic and
Which
the
is
value, I think.
Is it 1.685?
That's
Yeah.
what mine
Is it
says.
positive or negative?
Positive.
Mine is positive.
Okay. Then it has to do with how you put it in. Because Heather, you said it doesn't matter which way you put it.
Well, I don't know if that part does. I just know when you get the answer. I don't know. I don't want to say the wrong thing. But yeah, when you get the answers from what's the difference on those two, it doesn't really matter. You get the same answer, just one would be negative and one would be positive. Because if you have the difference between 4 minus 8 is 8 minus 4, you get the same answer, just one's negative and one's positive.
Okay. So we're doing positive 1.685.
Yeah.
And then p-value, do they say difference or less than?
It's just difference.
So then we leave it as
Yeah, so
it
you take it as is.
is, 0.096.
Wait, for the p-value you got 0.096, right?
Yeah.
Yes.
So there's insufficient.
Yeah, insufficient evidence.
To conclude that there's a difference in the mean cost of tickets.
Yes. So A.
Okay. Oh my gosh, are we finally done?
Yes.
Here we are.
I'm submitting.
Okay.
And I'm scrolling. And scrolling. And scrolling. And it's a long. Oh man!
What did we get wrong?
The very last one, 32.
What?
What?
Wait, and you picked A?
Oh, the test statistic. Look at it. It's 0.10.
Why?
Why?
Because they changed the test statistics. So
Did they change how many decimal places?
0.096 is lower. So there is sufficient evidence to conclude that there.
Oh.
Oh yeah, it is lower. Oh, sorry, I didn't look at it.
Yeah. So I think I got to go back and change that. But
Is that the only one we got wrong?
yeah,
Yeah.
everything else is right.
Yes.
I'm like, oh, now I got to go redo this whole test.
I know.
So
Oh, well.
which one is right for the last one? It is.
I think it's B. That there is sufficient.
Yeah, it's B.
Okay.
So,
Oh, one.
so yeah, you put that one that was different, right?
Which one?
I don't know. It was like
What number?
was it 18 or something? It was one where we were like, oh, we think the sigma is unknown, and you thought it was known.
That was right, whatever we did.
I think it's
Oh.
18.
Wait, you said it was right?
We picked A, and A is right. I don't know if you have put in or not.
I think I put it in as A. Yeah, for question 18, the confidence interval when it's unknown.
Yeah.
Yeah, I went with you guys on that one.
Okay. Okay, just checking.
What other ones did you get wrong, Heather?
I didn't get any others wrong.
That one. I'm same with
That
it.
was fun.
I think I put the same as you guys on everything else.
Yeah.
Okay.
Oh, 100, yes.
Yeah.
Oh, and now studying begins.
I know.
It took me so long to like study this all last time.
I like had a dream last night that our teacher like came over to my house and was like, "The test ends tomorrow. You've got to take it right now." And I was like, so that's why I woke up this morning. I was like, I gotta take the test.
I hate.
I'm gonna take it right after this while I have everything fresh in my brain.
I'm not ready.
Make sure, Leah, make sure you like go over Unit 1 stuff too.
Because it's both, right?
Yeah, because it is both.
It's like, oh.
See, like, what I did is I like wrote everything and I like highlighted all the questions they asked and stuff, so now I'm gonna like take that information from Unit 1 and like write it on my new sheet.
I know. I was like, I just want to use both. I don't want to.
Yeah, I know.
Gonna have questions from the first exam on it too?
Yeah, they're all cumulative.
Comprehensive.
No.
No, so in what's it called? In the Unit 2 review, it actually said that you should go through the Unit 1 review too again.
Man. I did not do that good on that last one, but that's because I didn't use SPSS at all.
Yeah.
I think you did do well in it.
Yeah, I think I'll do better.
I think you got better than I did. So,
What?
what are you trying to say? That I did bad? No, on our last unit review, didn't you get like an 89 or something?
I got an 89.
I think I got like a 70 something, but it is because I used Excel. So like all my numbers are a little bit off.
Yeah.
But now I've converted to SPSS.
Converted. I've seen that.
SPSS for life. I know, I have to, like, taking biostats is a prereq for, like, my master's program that I want to apply to, so I'm like, oh, I wonder, like, if I'm going to use SPSS later, or if this is just, like, a BYU thing, and I'm just never going to use this again.
You're going to use it in your daily life.
Oh, yes, I would like to see the difference between flights for myself personally, so I'm going to SPSS this.
That would be so funny. If you actually did that, email the results to me.
Yeah, it can be a good flight to Disneyland.
Oh, I can't go to Disneyland anymore. I'm sad. Don't talk about it.
Why? Did your thing expire?
Well, it expires. What day is it today? Is it the 9th? Yes, today's the last day I can go to Disneyland, and I'm so close to the biostat, so I can't go.